Okay, now let's talk about what is a statistic, because that's a little different than saying what is statistics as a field. What are the tools they use, etc. All right. A statistic is a calculated numerical property of a sample or a population. Let's stop there for a second. I might use your class, your statistics class, as a sample. And I might describe you in ways like, my statistics class is friendly. My statistics class is intelligent. My statistics class is inquisitive, etc., etc. Now, those are all properties of you guys. All right, I'm going to assume. I haven't met you yet. But when I'm recording this, I haven't met you yet. But I'm going to assume that that's true. All right. Now, it is a property of a sample. If I have defined you as a sample, I might define the entire campus as the population. You guys are my sample. But I could narrowly define my population in such a way that you are actually the population, right? If I keep saying, well, they have to be SUU, psych majors, taking SATs, psych 3010, section 1. Now, if I define my population that way, guess what? You guys are now my population, all right? But more than likely, I'm just using my class, you guys, as a sample of the SUU campus. So a statistic would be a calculated numerical property that describes you. So when I said that you're intelligent, you're inquisitive, you're friendly, those are not numerical properties. So those are not statistics. Now, if I gave you a friendliness test and you got a score, an actual number, then I could calculate something from those numbers now, and let's say calculate the mean, and then the mean would be a statistic because it's a numerical calculation. It's based on numbers. Just saying you're friendly, inquisitive, etc., those are not numbers. I can convert them if I develop a friendliness test, a curiosity test. If I can get numbers, then I can calculate a property that describes you numerically, and that's a statistic. Now, a statistic, a numerical calculation, right, property of the sample or population, can be either a parameter or an estimate. So let's look at the difference. A parameter is a statistic that was calculated on the entire population. So if I calculated the mean friendliness of every single SUU student on campus for fall 2020, which wouldn't be many, right? Sorry, that was bad. But anyway, if I were to calculate the, let's say enrolled, all right, so the mean age of every single SUU student enrolled in at least one class fall 2020, then that would be population. And any statistic I calculate using all those numbers would be called parameters, okay? And we represent, statistics using symbols. So, there's a symbol for the mean. There's all these different symbols that you're gonna learn about. All right, talk about those in a minute. Now, estimates. Estimates are statistics that are calculated from samples, not from populations. All right. Estimates are statistics, in other words, numerical calculations that represent a property of the sample. All right. So if I calculate the mean friendliness score in your class and you're only a sample, the class is only a sample, then it's an estimate. And it actually makes sense, right? Because a sample doesn't include everybody. So anything we calculate on the sample, by definition, must be an estimate, okay? Now, we're going to learn about how we represent statistics using symbols. And the nice thing here is that when we calculate something on a sample, the symbol we use is going to be an English letter. And if we calculate it on Greek, if we calculate it on the entire population, then we represent it using a Greek symbol. Okay? Now, one more thing, because we're running out of time. And in fact, I got a little timer here. I'm going to stop it so it doesn't disturb the lecture. Okay, so let's look at some of those symbols. All right, so if we saw this symbol we call it mu. Now, that's not an English letter. So right away, that tells you that it was calculated on the population. Now, what is mu? Well, it's the mean of the population. Okay, the symbol is mu. Now, mu is a parameter. It's a statistic calculated on the population, and the particular statistic is called the mean. All right. Now, don't confuse parameters with populations and say it's the same thing. A parameter is not a population. A parameter is a statistic calculated from a population. That's not saying the same thing, right? So parameters are not populations themselves. Parameters are statistics, and they're calculated on the population. So this particular symbol, Greek, stands for the mean of the population. This particular Greek symbol is sigma squared. That's how we say it, sigma squared. And it represents the variance of the population. Now, you probably don't know what variance is, and don't worry, you don't need to know right now. All right, it's a measure of variability, but we'll talk about it later. All you need to be able to do right now is to say that whatever this is, okay, it's a parameter. How do I know that? Well, it's Greek. And it's called sigma squared, and it represents the variance. All right, what is variance? I don't know yet. You might be saying, but that's okay. Whatever it is, it's from the population. Same thing here. This is the symbol for standard deviation. What is standard deviation? Don't worry about it. You'll learn it later. But it's a Greek symbol, and that means it's a parameter. It was calculated on the entire population. Over here, we have X bar and mu. X bar, did I say mu? I'm sorry. X bar, or M, capitalized M that's italicized. X bar, or this M, is the symbol for the mean, just like mu was, right? The symbol for the mean. But this time, because it's an English letter, we know it's the mean of the sample. So in other words, it's an estimate, right? It's an English letter. I know this is not quite an English letter. It's got a bar on top, but it's an English letter, an English symbol, which means it came from a sample, which means it's an estimate. And these particular symbols represent the mean. So mean of the population, mean of the sample. What about this? English letter, S squared, right? S squared is an estimate. How do we know that? It's an English letter. What does it represent? The variance of the sample, all right? So finally, this one, S, English letter, that tells us it came from a sample, which means it's only an estimate. And what does S stand for? The standard deviation. All right. So we're going to have to stop here because we're out of time. We'll pick up from this slide. And just to make sure that you understand this, just a quick 30-second summary. Parameters are statistics calculated on populations. They are represented by Greek letters. That tells you they came from the population. And at this point, all you need to know is that mu stands for the mean, sigma squared stands for the variance, and sigma stands for the standard deviation. These are all statistics representing the population. Estimates are statistics calculated on samples, and they are represented by English letters, as you can see here. And you need to know that X bar or M, that is capitalized and italicized, this represents the mean of the sample. This one represents the variance of the sample, and this one represents the standard deviation of the sample. You don't actually have to know what variance and standard deviation are, the definitions for those at this point. All right, well, I hope that was fun. And again, we're going to pick up from this slide for the next lecture.